Hello my dear students, welcome you all to EDIFIWAY Infinity. Today we are discussing the lecture 1 of the chapter Motion in a Straight Line. This chapter is also called as one-dimensional motion, and this chapter consists of many basic concepts that you will be using in the upcoming chapters too. So let's see what all are the main concepts included in this entire chapter. The main content involved in this chapter is we will discuss the introduction, that is we will discuss about the branch of physics called mechanics. Then we will learn different types of motions, rest and motion, scalar and vector quantities, distance and displacement, speed and velocity, average speed and average velocity, uniform motion and non-uniform motion, instantaneous speed and instantaneous velocity, acceleration, uniform acceleration and non-uniform acceleration, instantaneous acceleration, then kinematic equations for constant acceleration, and that is a very important topic. We have to learn how to derive 3 important equations. Okay, then we will have math tools, graphical analysis and some important graphs, then motion under gravity, equation for displacement in the nth second, stopping distance and stopping times, Galileo's law of odd numbers, and finally relative velocity in one dimension. And also we will have a lecture where we discuss about some special concepts and shortcuts that could help you score good in your competitive examinations. And also we will have a MCQ section where we discuss beginner level MCQ questions, NEET questions, JEE Main and JEE Advanced questions. Okay, so let's see what all are the concepts that we will learn in this lecture. Okay, in our lecture 1, we will have an introduction, we will learn types of motions, rest and motion, scalar and vector quantity, as well as distance and displacement. Okay, so let's see what is mean by mechanics. Mechanics is a branch of physics in which we deal with the study of motion of the bodies. Okay, so we can write mechanics deal with the study of motion of the bodies, and we can further classify mechanics into 3, that is statics, kinematics as well as dynamics. What is the word static means? Static means rest. So you will learn about rest. Okay, so statics means study about rest. Okay, then we have kinematics. What is mean by kinematics? In both kinematics as well as dynamics, we deal with the study of motion. Then you may think that, then why should we have 2 different branches? That is, in kinematics, we deal with the study of motion without considering the reason, that is the cause of the motion, how the motion has happened. Okay, we won't be discussing that in kinematics. But when we learn dynamics, we will learn the reason, the cause of the motion. That is, we will learn about force and all. Okay, so in kinematics, we study about motion without considering the cause of motion. Okay. Now we have dynamics. What is actually dynamics? In dynamics, we deal with the study of motion considering the cause, right? So we can write that as study about motion considering the cause of motion. Okay, so this is what you need to know about the different branches of mechanics. Now let's discuss what are the different types of motions. Okay, and I have classified the motion into 1 dimension, 2 dimension as well as 3 dimension. Okay, what is mean by 1 dimensional motion? 1 dimensional motion means you need only one coordinate to represent the position of the body that is executing the motion. Okay, 2 dimension means you need 2 axes in order to represent the position of the body, and 3D, that is 3 dimension means you need 3 axes in order to represent the position of the body. And 1 dimensional motions are also called as motion in a straight line. You know that, right? 2 dimensional motion means that motion is taking place in a plane or in a surface. Therefore, we can call that as motion in plane. And now think what will be mean by 3 dimensional motion? Yes, motion in a space. Okay, so I will give you an example for 1 dimensional motion. Let's consider a situation. Okay, let's consider a situation. A boy is walking through a straight road. Okay, so there's a straight road and here is a boy walking. Now, how to represent the position of this boy? You can consider this road as your x-axis, then this become x, this become x dash. You will have your origin, right? So this is your origin, and you measure the distance from origin to the position where the boy is standing. Suppose if it is 5 meters. Now clearly you can see that we can tell the position using a single coordinate. That is the speciality of 1 dimensional motion or motion in a straight line. Okay, and I will give you an example for 2 dimensional motion. There you need minimum 2 coordinates, right? So let's consider x-axis and also y-axis. Okay, this will be your origin. Suppose the boy is at a point, say A. Okay, the boy is at a point A. Then how to tell his position? You have to measure the distance along x-axis. Suppose if the distance is x1, and when you measure the distance along y-axis, suppose the distance is y1, then what will be the position of that point A? It will be ordered pair x1 comma y1, and also you can see that this motion is taking place in a surface, right, in a plane. So that is what is mean by motion in a plane. Okay, now I will give you an example for 3 dimensional motion. Yes, what are the coordinates? As you think, it will be x-axis, y-axis and z-axis. Okay, so let's mark. This is our x-axis. Sorry. This is your y-axis and this is the z-axis and this is your origin. Suppose the boy is again at the position A here in a space, then your coordinate will be ordered triplet x1 comma y1 comma z1. Clear? So this is how we give the position for a body moving in a space, that we need 3 coordinates. So that is mean by 3 dimensional motion. Okay, now we are going to discuss what is mean by rest and motion. Before discussing what is rest and what is motion, we need to know two important factors. Okay, that is time as well as origin, or even called the frame of reference. Okay, what is the speciality of time? Time is an independent quantity. Okay, time does not wait for anyone. It keep on passing. Okay, all other quantity, whether it is displacement or velocity or acceleration, all these physical quantity vary with respect to time. So you can tell that displacement, velocity and acceleration are all dependent quantity, and in which quantity they are depending? They are depending on time, because time is the independent quantity that keep on passing. Okay, so without changing time, you have to understand that, very important. Okay, without changing the time, you cannot change displacement, you cannot change velocity, and you will not have acceleration without changing the time. So time is an independent quantity. Now the next factor, that is origin. Okay, or even called the frame of reference. What is mean by that? Okay, I'll give you a very simple question, that is, where is your school located? Okay, that's a question. Where is your school located? So how will you tell the answer? You may tell that my school is located in a place A. Okay, or you may tell like this. More clearly, how can you tell? You may tell my school is 300 meter from the town A. Okay, so you are referring to the town A. From there you are telling the distance to your school. So your town A is the origin. Okay, so the town A is your frame of reference. So we can choose anything in our surrounding as the origin or frame of reference. Now, understanding these two factors, that is time and origin, now let's see what is mean by rest and what is mean by motion. Okay, for that I will give you a very simple example. There is a lamp. Okay, here is a lamp, and there is a boy, okay, standing at a distance 5 meter from the lamp. Okay, so you are telling the position of the boy with respect to that lamp, then that lamp is your origin. Okay, then that lamp is your origin. Okay, the lamp is your origin. Now, as the time passes, okay, you know time does not wait for anyone. Suppose if it is 10 o'clock now, after some time, after 1 hour, it will become 11 o'clock, then 12 o'clock, 1 o'clock, it keep on passing, right? So as the time passes, if the position of the boy with respect to that lamp does not change, means the distance is always 5 meter. Okay, that distance is not increasing or even decreasing. Clear? Then you can say that the boy is in rest with respect to that lamp. Clear? Now, the boy started to walk to his house. Okay, think so. So the boy is walking now. What happens? Yes, the distance will increase to 6 meter. After some times, again the distance will increase to 7 meters. Alright? And the position with respect to this lamp keep on changing as the time passes. So now you can tell that boy is in motion with respect to origin, that is the lamp. Clear? Now let's see what are the definitions of rest and motion. Clear? Rest means as time passes, the body does not change the position with respect to origin. Okay, and what is mean by motion? As the time passes, the body change its position with respect to the origin. Clear? Now, may I ask you a question? Okay, just think of this situation. Can a body be in rest as well as motion simultaneously? That is at the same time. Okay, think of it. Just think. What do you think now? Your answer should be either yes or no. Many of you will think no. Right? A body cannot be in motion as well as rest simultaneously. But the right answer is yes. A body can be in motion or in rest simultaneously. Then what decides that? That is the origin. Okay. I'll give you an example. Suppose you are traveling in a bus. Okay. Then you are in rest with respect to the seat in which you are sitting, or with respect to a co-passenger who is sitting near to you. Okay, if you make them as the origin, then you are in rest because your position does not change with respect to the seat in which you are sitting or the co-passenger near you. Alright? But if you consider something else, some building outside that vehicle as the origin, then you could see that after some times the position with respect to that building have changed. So you are in motion. Okay, so it is origin that decides whether you are in motion or you are in rest. Okay, so we can say that motion and rest are relative terms. Okay, now let's see what is meant by scalar quantities and vector quantity. Scalar quantity means those physical quantity only have magnitude and does not have direction. Okay, examples are time. You will not tell 6:45 in the north direction. Will you say like that? Never. You just say 6:45 p.m. or 6:45 a.m. right? So time is a scalar quantity in which you are telling the magnitude. Okay. Then mass, distance, speed are all examples of scalar quantities. Okay. Then what is meant by vector quantity? A vector quantity will have both magnitude as well as direction. Okay. Velocity is an example. When you are telling velocity, you have to clearly specify the direction. You are telling a car is moving at 5 km per hour in the north direction. Okay, then you are specifying the direction as north. Then that means velocity is a vector quantity. Okay, some other examples are acceleration, momentum, force are all examples of vector quantities. Okay, now in order to do the numerical questions, in order to do the problems, you need to follow a sign convention for vector. Okay, in this chapter you will follow a sign convention. What is that? There are two ways by which we can give the sign for vector quantities. Okay, the first way is, so let's discuss sign convention. Okay, convention. Yes, the first one is similar to your coordinate system, that is your xy plane. Okay, this is your xy plane, this is exact, this is x, this is x dash, y, y dash. Okay, and this is the origin. Clear? Now you know that in the right direction is positive x-axis, so that direction will be considered as positive. Okay, that should be considered as positive, which means if a boy or if a body, if an object is moving in the right direction, then that direction should be taken as positive. Okay, his displacement, velocity, acceleration will be all considered as positive because he is moving in the positive x direction. Okay, now if somebody is climbing a ladder, okay, then that is the vertical y-axis, right? Positive y-axis. So that direction should be considered as positive. Okay, then x dash will be considered as negative. Okay, that is if a body is moving in the left direction, then the velocity, displacement or acceleration will be considered to be negative. Okay, and this is also negative. A body moving in the downward direction. Okay. Then the physical quantities, that is vector quantity, will be taken as negative. Okay. And I will give you one more thing, that is, you know that we use it to specify the direction as north, okay, north, south, west and east. Okay, you have to remember this figure, okay. In any question that is specifying the direction, you must draw this figure, north, south, west, east, so that you does not get confusion or a mistake. Clear? So, from this, the east direction will be taken as positive, the north direction will be taken as positive, the west direction will be taken as negative, and the south direction will be also taken as negative. Is that clear? Now I will tell you the second sign convention, that is the second way. Second one is, suppose this is a body and this body is moving left, okay. So the direction of motion will be considered as positive, okay. Since the body is moving in the left direction, that left direction is considered as positive. So every physical quantity, every vector physical quantity in the left direction will be positive, and every vector quantities in the right direction, that is opposite to the direction of motion, will be negative. Okay, that is the other way for giving sign to the vector quantity. But you have to keep a thing in your mind, that is nothing but your second method is more suitable for problems involving one or two bodies. Okay, if there are more than two bodies, then it is better to consider the first way, that is the similar to your coordinate system. Clear? You can use both sign convention anywhere you need, but in order to avoid the confusion while going through the problem, you choose, it is better to do the first one. Okay, I prefer first one personally. Clear? Now let's learn about distance and displacement. This distance and displacement is a very important concept. Okay, what is mean by distance? Distance is the total path length covered by a body. Okay, then what is displacement? It is the shortest, remember the word shortest. Okay, it is the shortest path length between the initial and final position. Okay, I'll give you an example to understand that. Suppose there is a position A and a body is moving from A to B along this path. Okay, then the total path length the body covered is the distance. So this is the distance. Okay, then what is the displacement? You know, displacement is the shortest distance, right? So how can you take the shortest distance between starting? Your starting position is A and your final, that is the ending position, is B. Then what is the shortest distance? Yes, it is a straight line distance, right? Shortest distance. This will be your displacement. Okay. So from this figure, you can clearly understand what is mean by distance and what is mean by displacement. Okay. Now let's discuss some difference between distance and displacement. The first one is their definition, that is distance is the actual path length traveled by an object, whereas displacement is the shortest path length between the initial and the final position. And you already know that distance is a scalar quantity, whereas displacement is a vector quantity. Now, the distance can be 0 or positive, whereas displacement can be negative, 0 or positive. Why displacement can be negative? Negative in the sense, if the body is moving in the left direction, okay, then as the sign convention says, it is negative, right? So, as the direction is matter, it can be negative. 0 means the body's initial position and final position are same. Okay, then it can be also positive. Clear? Now, what about the SI unit? Okay, the SI unit for distance is meter. Okay, and for displacement also it is meter. And I will give you a very important relation. Okay, that is, you know, displacement can be negative, 0 or even positive, right? So we can write displacement is less than or equal to distance. Okay, this is very important. Clear? When it will become equal? Suppose a body is moving from A to B in straight line. Okay, then that body's distance as well as displacement will be equal, right? So we can say displacement is less than or equal to distance. Okay, so we have discussed many basic concepts, and in the upcoming lecture, that is in the lecture 2, we will be doing numerical questions based on this lecture 1. Okay, so stay tuned. See you all in the next lecture. Bye bye.